Okay, for the Snowflake project, we're going to model a two-dimensional part for the laser cutter. You need to consider positive and negative space, and you can do an elaborate snowflake or you can do a geometric snowflake, and I'll do a couple of videos to try to help with each one. You really need to consider your design intent. If you get to the end of your snowflake where you start patterning it and it's not working very well, you want to be able to quickly modify it and change it to make it work. So how you model this is really important, and when we talk about design intent, what do we mean by that is how are we going to change it down the road, perhaps not knowing how it's going to come out. So in this case, that means we're going to want to make sure the origin is at the center. Makes it the simplest, and you're going to want to think about how you're modeling it with sizes and so on. You probably will want to use the geometric constraints, regular polygon tool if you're doing something geometric, and you can pattern that. If you are going to do a more complicated snowflake, and I'll show a few examples here, you're going to want to do an insert image, which in Fusion is called a canvas. And I will demonstrate that in a separate video. For this project, demonstrate the full design process in your engineer's notebook. So you're going to document the constraints, research through ideas, brainstorm, make a brief concept sketch. You want to have an idea of what you're going to do before you start sketching on Fusion. And then you'll go ahead and model the part. And there'll be another video that explains how you need to submit your drawing sheet for the laser cutter. The size constraints, 90 millimeters by 90 millimeters by 2 millimeters, and then if you need a hole, you can drill a 1.5 millimeter hole. We're going to be cutting these out of acrylic, and all features need to be at least 1 millimeter. 2 millimeters is probably better. When you cut the plastic acrylic with the laser, it melts, so it makes it quite a bit smaller. So even though we're in metric, make sure you're making things, you know, a significant size, or your snowflake is going to fall apart when it gets cut out. Okay, so here we see some examples. We see the Yoda snowflake patterned 6 times, and of course the rebel sign down here incorporated into his neck. Here's a geometric design, and then there's another geometric design with the G-clef. So you can do something more complicated or something as a geometric design. Let's look at what a geometric design might look like. So you'll see here, I've already got some things sketched out. I'm going to go ahead and go in and edit that sketch. And one of the things that's really important is I've got construction lines drawn and sketched out so that I know I'm going to fit inside my 90 millimeter size constraint. The dimensions are really important on this, so make sure that we are 90 millimeters in size, or it's going to be too big. And scaling it's not going to work. You know, I was saying everything should be at least 2 millimeters. 1 millimeter would be the very bare minimum, and I'm going for 2 millimeters, which actually is going to be 4 millimeters of thickness. So, of course, what might we want to do with this? I've got a lot drawn out, and the best thing to do is to pattern bodies and convert bodies into a single body. That's going to be the best way to do this with a circular pattern. So first thing I might do is go ahead and mirror this. So I'm going to go ahead and mirror. You see I have this geometric design here and already drawn out. You can see I put in all kinds of geometric constraints to make it look like I wanted, and I put numbers in that I could change if I don't like what it looks like after I pattern it. So there's my mirror. I'm going to pick my mirror line, and I'm going to say OK. I'm going to finish the sketch, and I'm going to go ahead and extrude. When I extrude this, I'm going to select just the circle initially and extrude 2 millimeters. Okay, and in order to use my same sketch, I'm then going to go ahead and extrude again, and I'm going to make sure that I select new body, and also go 2 millimeters. And when it wants to join, it's going to say join, but I need to make sure it says new body. Okay, and the reason for that, if I make my sketch invisible, is I want that body to be separate, and then I want to join them together. It just makes it easier to pattern. So then I'm going to go in and create the pattern. Create a pattern with that feature. I can pick the circle or the axis to pattern around, and I could decide what I might want to do with 8 parts or 6 parts. If I would go 6 parts, the snowflake looks a little bit sparse, and maybe I would go with something else in between here to make the snowflake a little bit more complete. So I'm just going to go with 8 for now, say OK, and then this would be very important. Those are separate bodies. I'm going to want to combine all those parts into a single body. So it's just a measure of pointing and clicking. Okay, and we see I have 9 different bodies there right now, and go ahead and join them together into a single body after you have done your patterning. Okay, the last thing I probably want to do is drill a hole. I'm just going to eyeball a hole here above the origin. I'll go ahead and make it vertical. Finish my sketch and select my point, and let's drill through all a diameter of 1.5 millimeters. Okay, so that way I can have a hole to put a piece of fishing line through and hang my snowflake.